Let's be real, we're surrounded by batteries. They're in our phones, our cars, our laptops, literally everything. But they all share one super annoying secret. They degrade. They lose their charge, they lose their power, and eventually they just die. So what if we could design better batteries, way faster than ever before? Well, in this explainer, we're going to break down how artificial intelligence is completely revolutionizing energy storage. And it all starts with a problem we know all too well.
You know the feeling, right? That brand new phone that lasted all day now suddenly needs a top-up by lunchtime? And look, this isn't just a personal annoyance. This battery degradation problem is one of the single biggest technological hurdles we're facing, especially as we try to build a future around electric cars and renewable energy. We desperately need a breakthrough.
So why don't we just, invent better batteries? Well, the holdup is something researchers call the battery bottleneck. And the reason for it is that the traditional way we discover and develop new battery materials is frankly fundamentally broken. To put that in perspective for you, just think about the lithium-ion battery, the one that's probably powering the device you're watching this on right now. From the initial spark of an idea in a lab to a commercial product in your hands, that full process took about 20 years. 20! In a world that moves as fast as ours does, that's just not going to cut it anymore. It's way too slow.
The old way of doing things is this incredibly slow, step-by-step trial-and-error process. It's like trying to navigate a gigantic maze, but you're blindfolded. You just bump into walls, one at a time. But this is where AI comes in. It offers a totally new approach, a fast, integrated discovery process where we can explore millions of possibilities all at once, in parallel. It completely flips the script on the entire R&D game.
So how does AI actually pull this off? Well, its advantage comes from tackling the biggest headache in battery research. There's just not enough good data to go around. Real experiments are wildly expensive and take forever. But AI has a clever superpower for this. It can fuse different kinds of data together. Okay, so on the one hand, we have real-world lab experiments. These are the absolute gold standard. They're accurate, they tell us the ground truth, but each one can cost hundreds of thousands of dollars and take months to run. So the data we get is incredibly sparse. We just don't have very many data points to work with. And then on the other hand, we've got computer simulations. These things are fantastic. We can run millions of them, super cheap and super fast, generating just mountains of data. The catch? They're based on approximations of real-world physics, so they're not nearly as accurate as a true lab experiment.
So here's where the magic happens. Trying to make a prediction using just those few scattered, expensive data points is a nearly impossible task. It's an extrapolation into the unknown. But the AI does something much, much smarter. First, it takes all those millions of cheap simulations and uses them to build a detailed map of all the possibilities. Then, it takes those few, expensive, super accurate experiments and treats them like GPS pins on that map. The AI's job is to learn the relationship between the fuzzy map and the precise pins. Once it figures that out, it can make a new prediction just by finding a spot on its map and then using that learned relationship to translate it into a highly accurate, real-world result. It's an incredible trick that saves a ton of time and money.
But, making a good prediction is one thing. For an AI to be a true partner for a scientist, it needs to do something else. It has to know how confident it is in its own answers. It needs to know the difference between a calculated prediction and just a wild guess.
This concept has a name. It's called uncertainty quantification. And the idea behind it is pretty simple, but its power is absolutely immense. We're basically teaching the machine to have a little humility, to say, you know what, I don't know. And even more importantly, to tell us why it doesn't know.
And knowing that is a total game changer. Because when the AI can measure its own uncertainty, it can tell scientists exactly what they need to do to make it smarter. It can pinpoint the single most valuable experiment to run next, the one that will give them the biggest bang for their buck. This is what opens the door to fully automated, closed-loop labs that can discover new materials with very little human help.
Now, this might sound like something out of science fiction, but I promise you it's not. This AI-driven approach is already producing some pretty dramatic real-world results, and it's leading to a totally new way of thinking about how we design products. I mean, just look at this comparison. In a project with Samsung, A process that traditionally took 10 to 20 years of painful trial and error was compressed into a design cycle of just a few hours. The AI optimized for a whole bunch of properties at once, like lifetime and cost, and it came up with a new material for the cathode that was just dramatically more robust.
This unlocks a whole new way of doing business. Instead of designers for a new car or a new phone just picking a battery off the shelf from a catalog, they can now design a custom, bespoke battery specifically for that product. At the same time, the product itself is being designed. All of a sudden, material science is right there at the core of the design process.
And AI's impact doesn't just stop at the discovery phase. It's being applied across the entire battery life cycle. We're talking everything from optimizing the physical design of electrodes, to smarter quality control in the factory, and even to having the battery in your device predict its own health and tell you how much useful life it really has left.
All of this really leads to a super important point about the future of science itself. This isn't a story about machines replacing people. It's a story about augmenting human intelligence and creativity.
Really, you can think of AI as a powerful new kind of tool, like a microscope for the 21st century. It allows scientists to navigate a design space of materials so unbelievably vast, we're talking billions of possible combinations, that it would be completely impossible for any human to explore on their own.
So the AI handles all the complex, computational heavy lifting. And that frees up human researchers to focus on what we humans do best, asking the big, creative, what-if questions that are the real drivers of scientific breakthroughs and innovation.
This acceleration is happening at the most fundamental level of material science, and it really makes you wonder, if we can use this to solve the battery bottleneck, what other seemingly impossible challenges in medicine and climate and technology are now suddenly within our reach? What are we going to solve next?